Welcome to On.NET, a weekly chat with the .NET team and guests. Today our guest is Don Syme. Hi, Don.
Hey, good to talk to you all.
And my co-host today is David Stevens.
Yep. Hey, everybody.
So why don't you both introduce yourselves?
Yeah, sure. Hi, I'm Don Syme. I work at Microsoft Research in Cambridge, which is where I am just at the moment. I can turn my computer around, you'll see Cambridge out the window, but it's just gone dark. And I have been involved in .NET right from way back before it was called .NET, and I am the designer of the F# programming language. I've also worked a lot on C# and of course on the .NET runtime quite a long time ago now. And I'm also an open source contributor to the F# language and many of its libraries and tools. And I'm also a researcher. Yeah, that's also my job.
Cool. David?
And yeah, I'm David Stevens. I'm the program manager on the Visual F# language and tooling team at Microsoft in Redmond. And I also work on .NET debugging and a host of other .NET things. So, yeah.
Cool. How about we talk about F# a little bit first? I know that you guys want to talk about other things than F#, but there is a lot of talk currently about F# and why is F# unique in the .NET landscape, and why should people use it?
I guess David, do you want me to start with that one?
Yeah.
Yeah, okay, sure. So F# is a functional first programming language centered on the .NET platform. Ever since we first started doing F#, we emphasized that one of the key goals was to achieve multiple outcomes that are normally difficult to achieve together, to do with interoperability and, first of all, functional programming, mixed with object-oriented programming, mixed with interoperability to the very core of the F# design, but to achieve a level of succinctness and performance and strong typing and rigidity in code, sort of without trading these things off. So you have the kind of close to the succinctness of Python, and a kind of while keeping the rigidity, the strength of strong typing. We wanted to have a strongly typed language, which was also very flexible and enjoyable to use. You didn't feel like the type information was a strong burden, and as you used it. And I think we achieved all of that in F# 1.0 and F# 2.0 back in the last decade, and since then, we've added a lot of other themes into the F# language. It's a very expressive language in terms of its computational constructs. The async programming, which is now very popular across a lot of languages, has its origins in F# and I think has its best expression in F#. It's actually done better in F# than any of the other languages around. And we also... There's an ethos about F# about getting things done, achieving programming outcomes where you actually solve real problems, and so we're taking all the best parts of the kind of the ethos of languages that comes from the Lisp and functional programming and families. And also many of the Unix family of languages, and we're bringing that into the .NET ecosystem as the kind of language which encourages you to explore a problem space right from the start. People are doing, for instance, they'll start not by going create new solution. They'll start maybe by opening a script, grabbing some data, starting to explore with a problem space, starting to write some code to work out what a solution might look like. So that's some of the elements of what makes F# special, and people who use it often say it changes the way they think about programming. That can be in many It's a consistent thing we hear. Even if, for instance, they end up using some object-oriented design elements in their code, they'll find that those might be minimized down to the essence of a design pattern. There's a strong feeling in F# coding that you are boiling. You can start with an overly complex solution, and as you work it, the language naturally leads you to a very clear and succinct expression of a solution to many problem in many problem domains. And I think that's one of the things I value the most about the language when I use it is good code looks really good and very clear. Okay, so does that answer the question, David? Did you want to add more?
Yeah, it does. So I think a lot of people have been or still are intimidated by functional languages because they have this idea that it's something very academic and very mathematical and hard to understand. But in my personal experience, when I've tried to learn F#, I've actually found it to be very easy to learn. Even if it is actually a little unsettling at first because the concepts are different from what you're used to.
Yeah, this is one of the things I find
not difficult actually.
Yeah. So some of the things you touched on just then are some of the things I find most strange and difficult about the .NET community. And in some sense, so the idea that the academic, anything hinting at anything with academic origins must be rejected from the .NET community. Actually, has is unfortunately been it's an ethos and an element which is unsettling and hasn't served .NET well.
Yeah, I agree that it's unsettling because a lot of things about .NET are actually coming from research. I mean,
no, but it's kind of there's a bit it goes beyond that, which is that there's a real risk that many people outside the .NET community will label the .NET community as a dumb community. That's not the place where intelligent programmers work. Okay.
Oh, I see.
That does happen, and it really sometimes shocks me to see that being reinforced within the community. And now, because one of the strangest things about F# is it's absolutely simple to learn. Okay, I mean, it may take people out of their comfort zone because the first thing you do isn't type class, and it may de-emphasize inheritance or something. But for the vast majority of programmers, typing let x equal a list from 1 to 10 is very simple. Yeah, where often we found that. No, and I'm sorry, I've had .NET or Java programmers get genuinely confused by that exact expression. Let x equal the list from 1.10 close bracket, and they say, "Where's the data being written to?" And I say, "That's a strange." They want to say what objects are being created, and they say, "Well, I could explain it to you in those terms, but that's not how you need to think about things." But you show that to a 5-year-old or an 8-year-old or a 10-year-old, and they got no problem with that. Okay, so F# is really extremely simple, and it's odd that it almost like the .NET community needed some kind of narrative that they needed to reject. They needed to reject things, not just F#. It's applied to a whole bunch of other things as well, I think. And there have been elements of that all along, and I personally think we're at a great transition point in .NET as it goes towards open source in .NET Core and with C# and Roslyn. I think where I hope the culture around .NET becomes much more normal and embracing of innovation. And there's all sorts of innovation that's happened in .NET, but I think there needs to be an ethos where we encourage the very smartest programmers to come to the greatest runtime system in the world, because .NET is a fabulous runtime system with we want it to be the place where all the very best programmers in the world come to.
I can disagree with that. Can you tell us a little bit about your research?
Sure. Yeah. One of the nice things for me about there's been lots of fantastic changes in the F# world and in the .NET world. The move to open source is part of that. And one of the things that's happened is F# has begun to spread very widely with many, many different contributors to the language. So F# is no longer just about the visual F# tools. F# as a language is independent and open source and cross-platform and has a software foundation associated with it and so on. It's not all about Visual Studio. And that means F# is spreading in all sorts of ways, and I am in many ways just one of many, many contributors to the F# ecosystem. And my job is to think about the language design, and I keep an eye on the overall software engineering ecosystem, and I kind of try and make things move along in the kind of F# base generally. But lots of other people are doing that as well. And so what that's allowed me to do is to kind of step back more into research mode, beginning to step back to that. It's only really in the last 2 months or so that I've begun to feel that. In the prior work on F#, we were able to effectively combine research and language design and product in what we were doing. We were working on these type provider features about data integration into programming languages. We can talk a bit about those. They're just amazing features of F#. But that was a very special time of working. It was this kind of unique point where I got to combine research with product and with language design. That and to some extent the async work we did in F# also had that kind of feel as well. Async programming has a long heritage, but it was still delivering it was definitely sort of a research/development experience kind of bit of work. So, but looking ahead, we won't always get that. Not every bit of research is about extending a programming language. I'm certainly going to be doing the language design as part of my work here at Microsoft Research. But we'll also be I've been looking a lot at using the F# feature set in a research and development setting. I've been looking a lot at the Embrace system as part of cloud programming to kind of what can we do to take cloud programming forward using the F# feature set. So I guess my research interests are in data programmability through the type provider work and cloud programmability through the sort of Embrace and using the F# like feature set. And, well, all sorts of other things. Who knows what we'll do here at Microsoft Research. We've got lots and lots of exciting projects in the lab, and I may be involved in some of those, and we may be starting new ones as well.
Can't hear you, Bertrand.
Yeah, Bertrand, you just dropped off.
Yeah, I'm sorry.
There we go.
I muted myself to type something in the chat window and encourage people to ask questions.
Okay.
And I forgot to unmute myself. Yeah, I wanted to talk a little bit about other languages and ask you what other languages are you currently interested about and maybe taking some inspiration from. Are there any features from other languages that you're looking at with interest and that might be something that would be interesting to integrate under some form or other?
there's a space of things which are outside the F# language design, which totally fascinating. There's a set of features from Haskell, and there's a set of features in the kind of type class kind of implicit thing. I'm not currently working on that as a day-to-day thing, but it's an area which is of clear interest in language design. And there's other features which are in the air, or actually, solidly available in the kind of various functional programming languages, which are just definitely of a lot of interest. So kind of keep an eye on what's going on in that kind of space. There's a system called Midori done at Microsoft Research, which had a lot of interesting features in it. They did tracked exceptions very well, for example. Again, I'm not actually actively looking at that, but this is kind of, I'm looking around what's at the fringe of kind of just over the fence. When you're in the F# zone and you look just over the fence, what do you kind of see? And you think, I wonder if that could fly in the context of the F# language design, and could it meet the kind of criteria that I was talking about before? Some of these features don't really fit with the criteria that we have. So, for example, there's a class of language features which might require very strong theorem proving and a lot of annotations in order to really have code that has a logical kind of specification and prove to be correct according to that logical specification. Done wonderfully by Microsoft Research in a system called SpecSharp, but also available in a range of other languages. Now that kind of working tends not to quite fit the zone of where F# users are at, and the kind of sort of high productivity kind of scenarios which they're working on. They're still of interest, and you can actually do some of those things through various other annotation schemes and through automated property testing and other things. Dependent types and kind of rich, very, very rich type systems also kind of fall into that category, that they are definitely of interest, but probably not where we want to take the language, because it might tip it over a complexity kind of boundary as well. So these things are often about assessing, how much bang for buck would we get to bring this into the F# language design, and does it sort of augment and work very well with all the other features that are there in the language? Often you have to kind of, F#'s got a feature set, and you have to think about, well, how's it going to interact with all of those different things, and including with tooling, for example.
And interop with .NET libraries.
Interop is a consistent theme, most definitely, yeah.
Okay. David?
Yeah, I was just thought I had Don mention dependent types. There's a project called F-star from Microsoft Research that at least my understanding, I haven't spent a lot of time playing with it, but is an augmentation of F# or a riff on F# that adds some of these more advanced type system things as an exploration of them.
Yeah, and when you see what they're using that for, they're using it to write model implementations of security protocols for the TLS protocol, and which underpins everything we do on the web. And I'm very happy that they would go to that extra effort to augment the programming model just to write 5 or 10 programs in it, which are actually some of the most critical programs that, or at least they're models of the implementations that run the entire economy today. So they're a super high assurance kind of coding where you definitely want to go down in that direction. That's not the space where F# itself sits in. It's a big. You can do all that kind of stuff through other techniques, but yeah, it's definitely something that's kind of in the air in related programming languages. Yeah.
We're starting to get some questions from the audience.
Yeah. While we're doing that, I'll mention the Rust language. Rust is a very interesting language with in the kind of sitting between the systems and managed languages kind of space. Again, it's not the sort of language where you just pick up that feature set and put it into F# programming. The Midori project had a lot of kind of the M# language they did, which Joe Duffy has been blogging about recently, had kind of some exploration of a similar part of the design space. And it's all about making the language completely very safe with respect to concurrency and with respect to data races. Yeah, I think it's great to see language design progressing in that area. We're seeing a lot of good experimental language design coming out, and Rust I like that project as well. I like it a lot.
Okay. So the first question we have is from Ben. He's asking if you think that F# will get first-class lenses at some point. And I have to admit I don't know what this is.
Okay, so lenses are a technique. So one of the techniques that's often used in F# programming is immutable data. Okay, immutable data used to be a bit of a crazy thing to do when resources were extremely limited on the local machine, and the programming was all about controlling a set of usually user interface objects and state. But these days, programming has changed to be much more sort of receive inputs from the web, do some kind of transformation onto it, and then pass it on. And the use in those many parts of many phases of the call pipeline and also all the programming around it can often really very much benefit from immutable data. The problem, of course, is you need to update and progressively transform that immutable data. So you usually apply a set of diffs effectively. So lenses are effectively a way of specifying diffs to immutable data structures. Like I actually want, kind of specifying the path to the place where you want to make some kind of change, and then you can, and making sure that the language which you use to express those diffs is very succinct and clear and is language integrated in a very nice way. I think that's what Ben is asking for. So first-class lenses would be a bit like the first-class events that F# has. So in F#, when you go form.mouse move, for example, or that becomes an event stream, which is actually an IObservable object. Okay, you don't need to do as dot. I've forgotten exactly what it is in C#. So it's got language support for turning those events directly into the form that you want to how you want to use them as first-class objects. The first-class events in F# would probably make getter or getter setter properties sort of have that same kind of status, that they can be used in a kind of first-class way, not just to get the value of the property, but to kind of say, I want to make a change to that property. I want to make a change down an immutable data structure at a particular point. So there are some good discussions on the fslang.uservoice.com. So can I enter a little chat message over here? Is this one that I use? Where do we use for chat here?
I think if you use the chat that's integrated in Hangouts, we'll be the only ones to see it.
Okay, well, I'll tell you what, can you chat more broadly or not?
Yeah.
Okay, so I just put the link on.
So yeah, actually, yeah. If you go to the live page, if you go to the YouTube channel, you'll see our live stream, and there is a chat that you can use there. But in any case, if there are any links that you want to add to the description for this video, I can do it later.
Okay, so I was just pointing to fslang.uservoice.com. I did post a reply about the possibilities in the design space for first-class lenses, and it's not because it. Oh, obviously, when we come to language design, we tend to prioritize things which really unblock a scenario, and which So you can do lensing in F# today. So it's not it doesn't strike me as like a must do like today. There are lots of must do things that we have for F# at the moment. We have and also for the visual F# tools, which I also contribute to, and so we definitely have just a lot of work to do for, and I don't know if that would be top of the list, but I'm not opposed to the idea.
Great transition. Do you want to talk about some of those future features and the ones you feel are on top of that list?
Yeah, I mean, I was thinking a lot about this over the Christmas time, lovely time, and for the visual F# tools team, probably the top item is core CLR support. Just be a great cross-platform language with core CLR as a substrate. We're already a great cross-platform language with Mono as a substrate, and Xamarin as well for iOS and Android, which is absolutely wonderful that we've got such breadth for this language. I know the Visual F# Tools team with David really want to land good core CLR support, and it's well and truly underway, and so that's great to see. So that's occupying the attention of the team over in Redmond. On the for myself, I must admit I've got a bit of a feeling of that we've got technical debt from F# 2.0 through to 4.0, which I want to really cleared off. One of the things about moving to an open source way of working on GitHub is you more accurately track issues. Okay, there was a case that previously between, say, a 2.0 and a 3.0 and a 4.0, there was a certain sense that somehow between the different bug databases at Microsoft and just some issues got closed and lost. Things which I feel as border on the design side as things I really want to resolve in the implementation of F# or the design, the micro kind of detail of the design of F#. We also have some technical debt to do with aligning various parts of the F# implementation, which I'm involved in resolving, and in a sense putting us on a really good foundation to go forward. So one of the great things that happened in the F# world is the F# compiler service, which is like Roslyn for F#. Okay, so it's a component. It's actually just one DLL, F# compiler service DLL, and it gets used for all sorts of things. Now that's a fork of the F#, the core F# compiler repo, with a whole bunch of stuff stripped out and some new APIs added and published as a DLL component. And so one of the things we want to do is to do the engineering work to kind of reconcile that all, so that we rebuild the Visual F# tools on top of the F# compiler service. There's a lot of other tooling that's built on top of the F# compiler service, and we want to make sure that, so for instance, all the Emacs tooling, all the Xamarin tooling,
Ionide,
everything. Sorry, what's that? Ionide and for VS Code. It's a really and a lot of documentation tooling, all sorts of interesting things, crucial tooling, and above all, high on the list is the Visual F# Power Tools, an absolutely fantastic set of additions to the Visual F# tooling, which I'd encourage everybody to use. Everybody who's touching F# in Visual Studio, I encourage you to go and install the Visual F# Power Tools as well. Right, so there's a feeling of technical debt, a little bit on the language design or kind of micro corner cases of that, and so a few bugs, and on the F# compiler service and alignment. And I really am allocating a chunk of my time during the first part of this year to clear off that sense of technical debt. There's also a sense that the landscape is changing around us with F#, or in a sense, new opportunities are coming up, and Core CLR is a big part of that. being a great language on Linux is not just a matter of kind of getting Hello World to run on Linux. It's not even a matter of getting kind of all sorts of other code to run. You also have to, I think that's that. It used to be you have to have great packages, for example. We're now using NuGet as a package delivery mechanism more. So it's not just about that. You need great editing experiences. You need documentation that makes sense for the Linux developer that doesn't have Windows or sort of C:/ all the way through it in every sort of example. So I'm pretty keen to be great on Linux. We've come a long way with that already with Mono and F#. So we started that journey about 3 years ago in earnest. And the community is also doing a great job. There are some parts of the community that just do F# on Linux. For example, the Suave web server library is developed mostly on Linux, and that's for server-side web programming. A great library, I should add. But that feeling of change around doesn't make me feel like now is the right time to rush out a whole bunch of experimental features for F# 5.0, or it just feels like we should land F# as we know it and love it into the new world without necessarily having lots of other change. At least not to put the focus on that set of language changes. Lots of good micro evolution. Perhaps we have perhaps some headline language additions, but not. But the focus to me seems to be about the change. First of all, the change to CoreCLR and cross-platform, but that is actually a different kind of change as well. That's actually a change about the cloud as well. I think everyone would realize that one of the reasons why Microsoft is interested in CoreCLR and is because of its the growing importance of its cloud platform. And so there are all sorts of opportunities to be a great cloud programming, great scalable programming language as well. So I guess that's my thinking about where the next sort of 6 months, 9 months looks like.
Okay. We had another question about F# and Roslyn, but I think you've addressed that in your answer. The next one is, are you happy with the current interop between C# and F#, and do you think it could be improved on some areas?
David, do you want to take a first crack at that?
Yeah, I mean, I think the interop experience between the two is one of the better language interop things, at least that I've played around with. You can, I think for the majority of C# devs who are in Visual Studio, it's just, file new project. You can choose an F# project, and it appears there. Then you can reference types that you've defined in either language in the other. And so there's no sort of kludgy FFI thing going on. It's really nice experience to hand off between the two. There are certainly places where, if you use something like discriminated unions, where the shape of the type you're defining in F# might be awkward to consume from C#, and so pattern seems to be, folks, for example, if they write a library in F#, they'll write a C# project that's just sort of a shim on top of the F# one to make it really nice to consume from C# or the other way around. For the most part, in fact, every F# developer gets good at consuming C# libraries written by C# developers who have never thought about F# in their lives, and it all works really great, which is a testament to the way the languages have been designed to interact with one another. So,
with F# 3.1 and 4.0, we did do some work to improve the interop, through to link heavily overloaded methods. C# has evolved and changed in quite a lot since sort of C# 2.0, where the initial interoperability was designed, and so we had some rough edges in consuming some C# libraries. For instance, the task parallel library was a little bit difficult to consume for a while, or linked libraries was. We fixed nearly all of that in F# 3.1, so it's definitely on our radar to continue to look at that. And definitely there are cases where if things are unnatural to consume in F#, then we think about, I take that seriously. That's not the sort of thing I just push off and say, actually, no, we're not going to do anything there, unless fixing it would really deeply affect the way F# does things. There are, C# have added some micro features in sort of 5.0, 4.0, 5.0, which we also need to think about being better at operating with. Some things like named parameters drop out okay. C# has a major focus on nullable. We don't focus on that type in the same way, so interoperating the C# code that uses nullable a lot looks a bit different from F#, but it's not. It's totally doable. It's not that hard. I think the pain that people really do feel is on the Visual F# tools side, and particularly that there's no go-to definition from F# code to C# code or vice versa. And there's that alone would rate very highly on the requests for the Visual F# tools. Strangely, I've got a feeling that it must be possible to access that metadata about definition locations in C# somehow inside Visual Studio. We've never quite found a magical internal API call that would just give us where is the location of the C# identifier. But there are other ways of doing these things. There may be ways of finding a hook to just get the definition location. And if somebody wants to make a kind of one of those contributions where you get thousands of people saying thank you for that, then you might think about going along the Visual F# power tools initially, probably, and making a contribution to implement the go-to definition. That's assuming you're using some kind of not quite legit technique to get that definition location. A bit of maybe you run Roslyn behind the scenes, maybe use some reflection. Maybe use something that is not quite the right thing to do. But still, if you get it working, you will literally have thousands of people saying, thank you. That's made my life so much better.
Flowers at your doorstep. Yeah.
Yeah, and so it's always like I probably should announce a bounty. I'm not. I don't know what I'll give you, but I'll give you a signed. I tell you what, I'll give you a signed copy of Expert F# 4.0. There's Expert F# 3.0. But I haven't got the copies yet of Expert F# 4.0, which has just been printed. So I will send you a post, a signed copy of Expert F# 4.0 for the person who implements go-to definition to C# code in either even to strong prototype stage as a PR to the Visual F# power tools probably would be the place. If it's a totally legitimate technique, then in the Visual F# tools themselves.
Excellent. We have a couple of questions about community, actually, and how F# is very community-driven. The specific questions are, how satisfied are you? Well, how satisfied have you been with the community's efforts to experiment with F# language features? And another question, which is, how satisfied are you with the community's growth and efforts to produce learning and training resources?
Yeah, great questions. I didn't see the move towards open source as I didn't think that was the outcome I was hoping for. Wasn't that people would just do lots and lots of experiments to make variations on the F# language. So for me, we obviously get some people doing variations on F#, but it wasn't about that. So I'm totally happy with the amount of variations on F#. Because it's not about people doing experimental versions, it's about people making PRs which generally improve the language within its design zone. So one great one is from Kihan on GitHub, which is a PR to allow F# record types to be structs, just by putting an attribute on them saying struct. Now we haven't yet pulled that PR because we might also want that to apply. I want to see more testing, and I want to see more. We might also, particularly testing with regard to feature interaction, and I also want to strongly consider allowing that attribute to be applied to union types as well in F#. But that is just a great contribution from the language from the community. It's always going to take us longer to pull language features than people probably want. Anders Hallsberg had a saying, I think it was Anders or someone, that language features start with a score of -1,000, right? You don't. It's the last option is to make something a language feature almost, right? It's kind of the last thing you think about doing because it's expensive and it's got interactions and all sorts of other things.
So in this case, was it a PR that just came in one day, or was there some community discussion around the feature first?
We
have the site I gave, fslang.uservoice.com, is where we all the suggestions about F# go, and people can vote on them. And we close. I do the admin on that generally, although we might over time expand that to include other sort of key language design people. We close some of them. We also leave some of them open. Probably some of them in which people from this discussion could say, actually, we're probably not going to add that to F#, but I'm still actually genuinely interested in seeing the level of demand for some of those features. So we're getting an estimate for that. Some people say it's about crowdsourcing what have traditionally been program management at Microsoft Research. That you some people have also called it Don's personal Trello board. I must say, it's not. That's if it serves a role where we actually are able longitudinally to track these language features and keep the discussions in one place, a permanent record about them, and those discussions don't get mixed up with the engineering processes, which are in GitHub, for example. That's a good thing. This is it's serving a good role. There's also a sense in which language design discussions probably it's not a great discussion site. I guess that's the biggest criticism of that site. It was the best we had available at the time. That we made that choice. It actually, to move all those 200 language suggestions and the entire history and all the votes and everything away from that service now would be a really major undertaking. That would take me like a week or something, and we would lose a lot of history in that process. So that's where we are for the language design. It certainly serves my personal immediate needs in being able to track items, mark them as approved, give links across to the PRs, and so on. Now, of course, for the language feature we were just talking about, it's a very small, syntactically very small feature. Just add struct on as an attribute, and you have a struct. We had I already had an item on that, and I think I had probably indicated that we would strongly like to see this would be approved. Or sort of pre-approved kind of note. So we separate out the approval of language design items from their implementation. So in a sense, we can go through and approve a whole set of design items for some future version of F#. And you can go to the site fslang.uservoice.com and take a look what's sort of been pre-approved for future versions of F#. And then people are definitely invited to give implementations to those. Now, those implementations do need to have really good testing, and they need to be really solid, solid code. I'm really sorry if we have to reject PRs. I got to say, in that, one of the things that hurts the most is to have to press that close button on a PR. People have been saying that the PRs are open too long on the Visual F# site, right? There's a reason for that, and that is sometimes PRs actually are a very good idea. We want to encourage that. Some particular items, sometimes we want to encourage, we're full on with experimentation for some item, but it's actually quite hard to close a PR when it's not quite the right time to take it.
Yeah, and when it's obvious that people have put a lot of work in it, it's always a difficult thing to do.
Certainly.
No matter what.
No matter how much work actually, submitting a PR is just always work, and no matter what, they've taken the time to make a contribution, and I would rather we kept the PRs open and had a positive discussion about how we can think about something, how we can take something forward, rather than we're put in a situation where we either close or take, close or take, close or take. I don't want to do that. Rather, we make sure that every discussion we have is a positive one. And having positive discussions in design discussions is not easy, right? It takes time. It takes time to write things with care, to understand where another person is coming from and why they're actually making this suggestion. So I'll give you one example of that. We had an optimization suggestion come through last night for improving the performance of array.average in the F# library, and also some other related suggestions. Now the array.average suggestion, top would just straight away. I can tell straight away. We have to do proper testing and so on, but I can tell straight away that that's going to be a good contribution. The other ones actually weren't going to achieve, I think, what the person who submitted the PR intended them to achieve. But fortunately, I had actually seen I believe the person making that suggestion had been working on a library called the Streams library, which looks like a fantastic library for spreads. It's called the Spreads library for event processing. Event processing library, and so I had more context. I understood why they were making that change and what optimization they wanted F# to be doing for them. Now it's actually not quite as simple, unfortunately, as the attempt made out to get the effect that the person wanted. But at least I had the context. I knew from following that library, I knew why they were making that suggestion. And I find once you understand people's motivations and context and what they really want here, then you can have a good technical discussion from that point.
Okay, so Chris has a question here. How much value do you think that parametric polymorphism of modules and/or functions, something a la type classes, would have for F#?
Okay, so this is kind of a question where there are two separate questions. One is a set of features where modules in a language called OCaml, which is related to F#, can take these extra parameters, and it adds there are things you can do with a module system which you can't do in the existing F# kind of language design. That is kind of purely technical level. So that's a feature called functors from OCaml. There are actually good discussions about that, I think, on the Stack Overflow or fslang.uservoice.com. I would actually ask the question the other way around, which is think about the value of the F# feature set for those languages. I think the features we actually have in F# are actually probably of higher importance in the stack. For instance, the async programming and some other features. So functors are not something that sit particularly easily with the set of object features in F#, and so they're probably not something which is top of list for adding to F#. Type classes are a way of sort of passing parameters around implicitly, sort of piling up a load of functionality which gets inferred from the set of type arguments that come with a function, and it's definitely a very powerful feature. It makes your code more implicit. It can have a downside of making code harder to understand because more is being passed implicitly. Used well, it can make a huge difference to the clarity of code because a whole lot of incidental kind of parameter passing gets sort of you no longer see it. Type classes, something in the type class space definitely has lots of valuable uses, and there's no way that I would say never with regard to type classes or some variation on implicits or type classes in F#. There are some nice proposals for how to implement that on .NET in a way that actually gets very nice efficiency. It gets very nice performance, because one of the problems is if you're passing things like the add function around as an implicit parameter, then that can actually get to then calling that add function might involve an indirection, which can be dreadfully slow. So you want to avoid that. You want to really make sure that you don't go down that route. So it's a definite. I roughly know what I'd like the core of the design to be, or the implementation actually, in a way. I guess I know if we did something there. One of the hard things I find about actually trying to do that in F# is it can add an extra concept to the language. F# at the moment is really quite simple. You have type definitions and you have let, okay, and modules which can be used to hold those things. So there's a number of different kinds of type definitions, but it's still pretty straightforward. You basically all day long you're going create types and let. Yep. And that's really, really simplifying in programming. If you had type classes, then you just add this new idea of a constraint on type parameters, and it's a different. It sits uncomfortably with interfaces in particular. Now, there is good research on making these things sit more comfortably together. So I think that feeling that a feature might add another burden to the set of things that a F# programmer might need to learn, that's one of the concerns I have. I don't want to complexify the language. It's a sweet language to use now, and you have to be careful not to. Every time you add a burden, you can lose programmers. Okay. And everything we're seeing at the moment, F# spreading all over the place. All sorts of people are picking it up, and we just have to think carefully about that. I'm actually so happy at the moment that the spread of the language and the culture we have, the community we have around it, all just really great things that I want to be just mindful of keeping. That we have got a sweet spot, and we want to stay in that sweet spot.
To build on that a little bit, so you've watched F# go from a personal project to something that's used all over the world by, tens of thousands of people all the time. So how do you think about growing the ecosystem? And so for people watching who might be working on some project of theirs, like, what were the ways that you sort of got the ball rolling, and then how, in this stage of its life, how do you think about growing the ecosystem?
Well, I think that question goes not only to F#, which has a great ecosystem to it that I'm very proud to be part of, but also to .NET. I said at the start how I think the culture around .NET, where I've got a great opportunity to just make a fabulous culture for all the .NET languages and all the fantastic upstack kind of frameworks that are being developed. One thing I personally try to do is to help people who have open source projects, or actually potentially some kind of commercial kind of activity as well, to just give solid advice about how they can maximize their route to success. Not all open source projects succeed by any means, and but one example I'll give is the math.net library. Wonderful library in the ecosystem. Now, the first time I did this, I went to math.net in about 2012, and kind of math.net at that time had quite a lot of different websites. Okay, it had like 6 or 7. It had been on Codeflex. It was half on GitHub. It had its own site as well. And I could tell, if you position yourself not as a criticizer, but as imagine yourself, what would it be like to be on the .NET team? Okay, on the math.net group of core contributors, and you could see actually the documentation had probably got a bit out of hand. And I went through just to myself and made a list of every resource I could find by looking at Google about math.net. Just a getting started experience. The getting started experience of going to Google. People type in some search term like math library C# or something like that, and just see what comes up. And then like, is that information clear, and how simple can we make that getting started experience? And I wrote out all these pages, and I thought to myself, what would be the right solution here to make this thing right, that was really to make it healthy. I wrote out a proposal to Christoph, who I hadn't met at that time, Christoph Rueg, who's the lead contributor, and sent it to him in private email. And by the next day, he cleaned up the entire lot. It was all like and I think he just actually needed someone to say, hey, why don't we make it look like this, and make it look it suddenly looked really simple and really approachable. So so I've also helped a bit with Embrace. That's another link I'd love people to look at, embrace.io. We haven't had much time to talk about that. Wonderful wonderful cloud programming project and open source project, and they've got a really lovely, simple getting started experience. One of the best getting started with the cloud experiences that we know of in the industry today, for sort of getting started with scale out programming in this case on Azure or on a local simulator. So that on the sort of community. I put those in the community upstack technologies. So the things that sit on top of F#, that sit on top of the core runtime, on top of the core library, and they offer functionality in cloud programming or math programming or whatever. So I think that's been one of the things I've really seen happen with F# over the last few years, and I've tried to help out where I can. A lot of other people are contributing. It's just the development of a really great set of upstack technologies in all sorts of areas, and that's ultimately what will really drive platforms to success. When there's, we just need .NET just needs to have not only great web programming. There's a few options for that. .NET needs to have absolutely fantastic scale-out programming. There's no reason whatsoever that .NET Core in the long run shouldn't be one of the best environments for computational kind of workloads, for any kind of data programming kind of workloads as well. I think that's what really grows a community and grows a set of technologies that people are really excited to talk about as well.
Cool. And I think that is actually a fitting conclusion to this discussion.
Okay.
Thank you so much for speaking with us today, Don.
Okay, yeah. Well, thank you, Bertrand, and thank you, David. It's been wonderful. And sorry if we didn't get to everybody's questions.
Well, there are other places where people can interact with you. Actually,
who have you got on next week, Bertrand?
So next week we are going to talk about NATS, which is high performance queuing and messaging system.
Great.
That is actually, the server is built on Go, and they released a .NET client, and we're going to talk about that.
Excellent. Yes. Yes.
Very interesting topic.
Yeah, I think the space of .NET clients to all sorts of other functionality is crucial for driving the .NET forward, and I think it's good to see .NET shift out of the mode where things are all about sitting on top of Microsoft technologies. That's
exactly
kind of where it interoperates with absolutely everything.
Yep. All right. Well, thanks again. And we'll talk again next week. Thanks to everyone who submitted questions, and have a nice week. Bye-bye.
Bye.